Hello again. Today we're going to talk about confined spaces in construction. So we're going to have an overview of OSHA standards and on confined space hazards. So first of all, we're going to identify what is considered a confined space, and then we're going to talk about different responsibilities of different personnel who might be involved with that confined space and how to have the maximum protection when we have to do some work inside a confined space. So the objectives are going to be to define the confined space, define permit required confined spaces, OSHA standards on confined space, and finally understand what are the major hazards and how to protect ourselves against these hazards in a confined space. So the definition, first of all. A confined space, according to OSHA, is a space that it has to meet all of these three conditions. It is large enough to get into and work inside of. So if it's just a very small space where no one can get into, it's not considered a confined space in this case. Number two, it has a restricted means of entry or exit. It might have a small entry hole, for example. In this case, would be a confined space. And it's not designed for continuous occupancy. So, for example, if you have a small closet for storage of materials or equipment or whatever, but that closet is large enough for someone to get inside and work inside, then it would not be considered a confined space, because the confined space is not designed for continuous occupancy. So, when we talk about permit required confined space, not every confined space is going to require a permit. So in order to qualify as a permit required confined space, or PRCS, a space is going to have to satisfy the first definition of being a confined space, which we saw on the previous slide, and then it is subject to unsafe atmospheres, toxic atmosphere, or flammable contents, or oxygen deficient, does not have enough oxygen for sustainable breathing. So if it has any of these three conditions, not all of them, just any of these, in addition to being a confined space, then for someone to work inside that confined space, they have to have a specific and special permit. Examples. Well, basically this lecture is going to talk about the scope and application, the definitions, general requirements including the written plans, what are the permit required confined spaces, what is the permit system, what is the entry permit, what kind of training the employees have to be subject to, what are the duties of the authorized entrants, duties of attendants. Notice the definitions here. We have something called authorized entrant, we have something called attendant, we have something called entry supervisor. So these are three different positions or occupations. We're going to talk about them in detail. And then we're going to talk about the rescue and emergency services if someone loses consciousness inside that confined space that requires a permit. And finally, employee participation in that safety program. This is related to Appendix A. All of these are inside in your book, in your code book. Permit required confined space decision flow chart. Appendix B, procedures for atmospheric testing. Appendix C, examples of permit required confined space programs. Appendix D, confined space pre-entry checklist. What should you check before someone enters a confined space requiring a permit? Appendix E, sewer system entry. And Appendix F, rescue team or rescue service evaluation criteria. So we're going to talk about some of the characteristics of a confined space. First of all, the internal configuration, what may make it even more difficult to work with, in addition to the previous conditions that we have mentioned. We're going to talk about the elevation. We're going to talk about the portal size, which is the entry or exit portal, the way through which you get in or out, and space access orientation. So is it horizontal, is it going to be vertical, and so on. With the internal configuration, we have either an open confined space or an obstructed confined space. An open confined space has no obstacles within the space. Example is a water tank. Water tank, huge water tank used for storage of water. It has a limited entry port. it's not used or supposed to be for permanent occupancy, and so on. And the other option is, in this case, rescue is less difficult because, again, there are no obstacles that we have to maneuver around. The other one would be an obstructed confined space, which has obstacles including baffles, mixing blades, scaffolds on the inside of that space. In this case, rescue is going to be much more difficult. To give you an example here, if we have the drum of a transit mixer, that's definitely a confined space. It is obstructed because it has baffles on the inside. It has the blades that rotate the concrete inside the drum, and it has a limited portal. It's sloped, so again, access by itself is not going to be the easiest thing. So in this case, rescue is definitely more difficult than the previous example. The second one is elevation. We have either non-elevated or elevated. If it's non-elevated, access portal is less than 4 feet above grade or above ground, above the level where you are entering from. So even if it's on a suspended slab, it's less than 4 feet above that slab, the surface of the slab. In this case, again, rescue is less difficult because no one has to jump in. You can just get in without much hardship. The other one is elevated. If the access portal is 4 feet or more above the grade, you have to remember that cutoff number, which is the 4 feet. So if the access portal is 4 feet or more above the grade, then rescue is more difficult. So if it has obstacles and it's elevated, that definitely makes it a double whammy. The third one is the portal size. The portal size. Unrestricted is an opening of larger than 24 inches in the least dimension. So if it's a rectangle, the shorter side is going to be 24 inches. If it's a circular port of entry, then it's going to be the diameter that has to be at least 24 inches. Then in this case, again, rescue is less difficult. Restricted, an opening of 24 inches or less in the least dimension. In this case, rescue is more difficult. So again, we talked about the elevation, we talked about the obstruction, and we talked about the portal size. The fourth one is going to be the orientation, the space access orientation. If it's horizontal, then most likely the portal is going to be easier to access. Someone can even crawl in. If the portal is located on the side of the permit space, rescue is normally less difficult. But if it's vertical and the portal is at the top of it, most likely it's going to be more than 4 feet high. So if the portal is located on the top or bottom of the permit space, vertical portals may require special patient packaging to rescue, to extract the employee from that space. So rescue is normally more difficult. So these are 4 descriptions or characteristics of confined spaces that we have to take into consideration when designing our program and our rescue procedures. Here are some examples. This is a storage tank. Now, which conditions are going to be here? If it has baffles on the inside, then it's going to be obstructed. Obviously, that's elevated. Most likely, that's going to be more than 4 feet above ground. Well, although the storage tank itself is horizontal, but the entry portal is vertical, not horizontal. Now, depending on the dimensions of that entry portal, the size, if this is less than 24 inches, that's going to make it even more difficult. Silo, again, although it is vertical, but the entry portal is horizontal, it might or might not have baffles. So again, it's going to have some of the limitations of a confined space. And obviously, a silo is not designed for permanent occupancy, and there's going to be lack of oxygen inside silos. Many people unfortunately get trapped inside and they die. A pipeline, although it's open from both sides, but again it might be too long. Something like a culvert here, for example, again it's at, we can't even say that it's at ground level because it's on water in this case, which makes things even much more difficult to access it and extract people from the inside. So again, these are examples of confined spaces. Now we have to learn about some toxic gases and their weight and their volume and their density, whether they are lighter than air, so they're going to float to the top, or they're heavier than air, so they're going to sink to the bottom. So we have here, for example, 3 killers, 3 toxic gases. One of them is methane, which is lighter than air, so it's going to accumulate close to the top surface. This is a manhole, for example. Carbon monoxide, that's called the silent killer because it's odorless, colorless, and you can't distinguish it. That's why, unfortunately, even in residences, you might have the carbon monoxide detector that can detect an increase in the concentration of carbon monoxide, which deprives the air of its oxygen, trying to become carbon dioxide, so deprives the air of the oxygen. That's why it's asphyxiating. And the third one is the hydrogen sulfide, H2S, which is heavier than air and that sinks to the bottom. So if you are in an environment that has methane, crawl, because the methane is going to move above. If you are in an environment that has hydrogen sulfide, then stand up, because again it's going to try to sink to the bottom. If you are in an environment that has carbon monoxide, definitely get out, because it's going to be suspended in the middle depending on the height of that confined space. Here are again some examples of confined spaces. You're going to need a ladder to access it, and that hopefully is going to be more than 24 inches in diameter. So here, for example, we have different people helping the entrant, the person who's going to work inside, and obviously they have the proper breathing apparatus, like a scuba diving gear with compressed air on their back. So, and they have the gas mask and or the oxygen mask and everything, so they can work inside a confined space that has either noxious gases or poisonous gases or flammable gases or even lack of oxygen. Some other precautions would include, for example, having a ventilating fan and a trunk hose to keep renewing the fresh air inside the confined space. If you're going to do any welding inside the confined space, or if you're going to do any painting which has some fumes that emanate from that paint, so in this case you need to refresh and renew the air inside that confined space. And we have either air purifying respirators, which can either be a half mask that covers only the nose and mouth, or it can be a full face piece that covers also the eyes, which might be affected by the toxic fumes. So do not use in oxygen deficient atmosphere, because that does not provide oxygen. All it does is purify the existing air. So if the existing air is deficient in oxygen, then these are going to be totally useless. Therefore, do not use in oxygen deficient atmospheres. On the other hand, air supplying respirators, these can be used in oxygen deficient atmospheres, because here it has the air either attached through a hose to the tanks or carried on the back, which is the self-contained breathing apparatus, SCBA, scuba, called scuba basically. And here's the supplied air respirator with auxiliary escape only SCBA. So there's going to be a tiny, maybe there's going to be a tiny canister of oxygen just for the escape, but otherwise it's going to be totally separate from the person working inside the confined space. Some things that you should know about the atmosphere inside the confined space, that there's a certain limit within which you should not work. With oxygen 6% by volume, in this case it's going to be difficult breathing, death is going to happen in minutes. If it's less than 19.5% oxygen concentration, minimum for the safe entry. So do not enter the confined space if the oxygen concentration is less than 19.5%. Let's say 20%. 23.5% is fine. That's called oxygen enriched. At 16% oxygen concentration, you're going to have impaired judgment and heavy breathing. At 14%, it's going to be faulty judgment and rapid fatigue. At 6%, it's going to be almost impossible to breathe, and that's going to cause asphyxiation. So the safe range is anywhere above 19.5, and this is the dangerous range with its different danger limits. Now, in order for an ignition to happen, an ignition requires three different things. First of all, a flammable atmosphere, which is going to result from air. These three components: air, you have to have air to help the combustion; gas, vapor, or dust, that's the combustible; and source of ignition, that's going to cause a spark to ignite that combustible in the presence of air. So this is the ignition triangle that we try to avoid forming these three conditions at the same time. Now let's talk about the different responsibilities of people who are going to be dealing with permit required confined spaces. The first one is the authorized entrant, and that's going to be authorized by the employer to enter a permit required confined space. That's the definition: authorized by the employer to enter a permit confined space, permit requiring confined space. So that's the person who's going to work inside that confined space. All employees required to enter into confined spaces must be instructed as to the nature of the hazard involved, the necessary precautions to be taken, and the use of protective and emergency equipment required. So to become an authorized entrant, you have to satisfy these three conditions. You have to know what's the nature of the hazards involved, whether it's oxygen deficiency or toxic fumes or whatever. You have to know what are the necessary precautions to be taken, whether you have to work at a certain level because the gas is going to sink to the bottom, or what kind of protective equipment and you should have on you when entering that confined space, and what are the different symptoms of exposure to that hazard and how you should leave that space immediately. So the duties of the authorized entrant is to know the hazards regarding the space, know the signs or symptoms and consequences of the exposure to hazardous atmosphere. So if you feel dizzy, for example, or if you cannot breathe easily, that's a sign of oxygen deficiency. Know how to use the equipment properly, and communicate with the attendant, which is the second person here, to enable attendant to monitor the entrant status. So the entrant has to satisfy all of these four conditions. Duties of the authorized entrance also include exit from space as soon as possible whenever an evacuation order is given by the attendant, or an evacuation alarm is activated, which might respond to oxygen monoxide, for example, or the detection of a certain gas or fume or smoke. Symptoms are observed regarding exposure to hazardous substances, whether these are reflected through a change in the color of the skin, for example, or something like that. So, as we just mentioned, you exit from the space as soon as possible when an evacuation order is given, or an evacuation alarm is activated, or symptoms are observed regarding exposure to hazardous substances, or other prohibitive condition is detected. So, for example, if there's a lack of visibility or something else that's going to be preventing you from working properly in that confined space. Going back to the definitions, we learned about the entrant. So the second position that we talk about is the attendant. The attendant is a person stationed outside who monitors the authorized entrance and performs certain other duties. So that's someone who basically is there to keep an eye on the entrant and make sure that everything's going fine inside that confined space. And some of the duties of the attendants, very similar to the duties of the entrant. They should know the hazards regarding the space, know the signs or symptoms and consequences of exposure to the hazardous atmospheres, is aware of the behavior effects of exposures to hazardous atmospheres, etc., and continuously maintains an accurate count of authorized entrants. So you may have one attendant for several entrants in the confined space. He should be able to keep a constant accurate count of them through visual connection or verbal communication with them while they are in the confined space. The attendant has to remain outside the permit space during entry until relieved by others, because again, if they enter the confined space, they become an entrant and not an attendant, and they lose that capability of warning others about hazardous atmosphere or environment inside that confined space. communicates with authorized entrants as necessary to monitor entrance status. So again, keeping a conversation with them to make sure that they are still alert and everything. And monitors activities inside and outside space. So if there's something that's going to block the entrance, for example, or the exit from that confined space, they should make sure that they remove that obstacle to make it clear for the entrance to be able to get out if they need to. Other duties: order the entrant to exit if the attendant detects a prohibited condition, or the attendant detects a behavioral change in the authorized entrant. They are not fully alert. Attendant detects a situation outside that could endanger the entrance. So again, if there's a vehicle, for example, that's going to come close by that may block the exit route for the entrance, and the attendant can or if the attendant cannot perform his or her duties, if they need to be on, if they go to the restroom, for example, or whatever, then if they cannot keep that constant communication and contact with the entrance, they have to call for someone else to take their place, or if there's no one else to take their place, then they have to order the entrance to exit until they find a replacement for that attendant. In case some of the entrants are not feeling fine, or there's a problem inside the confined space and they cannot get out on their own, then the attendant is going to summon rescue as soon as possible whenever necessary. Warn the authorized persons to stay clear. Warn the unauthorized persons who are not supposed to be close to the confined space to stay clear, to make it easier to extract the ones who are inside if they need to be extracted. Alert entrants if unauthorized persons enter, and perform non-entry rescues as needed. So as we said before, they can perform rescue as long as they do not get inside the confined space. And perform no duties that might interfere with the attendant's primary duties. So when they are an attendant, that's all they do. They're not doing anything else to keep full attention on those who are inside the confined space. The third position is the entry supervisor, and that's an even higher position. So we talked about the entrant, we talked about the attendant, and the third one is the entry supervisor. The entry supervisor determines if entry conditions are acceptable, oversees the entry operations, the whole schedule, the whole scenario of the operation, and terminates entry as required. If there's any condition that makes work inside the confined space hazardous, they would terminate the entry. An entry supervisor may also serve as an attendant or as an authorized entrant. So there can be a dual role in this case. But if they're going to act as an attendant, then that's all they can do. They do not do any other positions. So the attendant will have the authority of the entry supervisor. And if there's an authorized entrant that has this power to end the entry whenever needed, then again they can assume that responsibility. The duties of the entry supervisor very similar to the previous ones. Know the hazards regarding the space, verifies that the permits are completed properly, all tests required for the permit are completed, and all procedure and equipment are in place before endorsing the permit and allowing entry to begin. And terminates the entry and cancels the permit as required if any of these conditions are violated. Verifies rescue services are available, that should be before the entry, removes unauthorized people from the area, and determines whenever responsibility for a permit is transferred that entry operations remain consistent with the terms of the entry permit that were issued in the first place. Another definition is about hot work permit. What kind of work is going to be considered as hot work? The employee's written authorization to perform operations capable of providing a source of ignition. So if there's going to be something causing a spark, for example, whether it's grinding or welding or any other operation that's going to result in some sparks that can cause ignition, then it's going to be considered a hot work environment that requires a hot work permit. Engulfing is the capture of a person by a liquid or finely divided or flowable, like a powder, solid substance that could smother or crush a person. So if someone's working inside a silo, for example, a grain silo, being engulfed by the grains, that can smother by deprivation of oxygen or crush due to the pressure of that huge amount of grains. It can kill a person. Entry is when a person passes through an opening into a permit required confined space. The entry includes the ensuing work activities in that space. Entry permit, or just permit in this case, is a document provided by the employer to control the entry into permit space. A permit required confined space is a confined space, as we described it before, a program means for controlling the entry into the confined space and for protecting employees from the hazards. So we need the ultimate goal is to protect the employees who are working inside that confined space. As we mentioned before, oxygen deficient atmosphere is an atmosphere with less than 19.5% oxygen by volume. Oxygen enriched atmosphere is an atmosphere with more than 23.5% oxygen by volume. You should remember these two numbers. Hazardous atmosphere is one that may cause employees to be injured, killed, incapacitated, or impaired, again through lack of oxygen or something like that, from one or more of the following causes. First, flammable gas, vapor or mist, in excess of 10% of its lower flammable limit. When we talk about a flammable gas or vapor or mist, it can only ignite within a certain range. The bottom line of that range is called the lower flammable limit, below which it's too lean to ignite, and the upper flammable limit, beyond which it's too rich to ignite. So it does not have enough oxygen or enough air to help with the ignition. But anywhere in between the LFL and the UFL, the lower flammable limit, and the upper flammable limit, this is a dangerous situation. Another condition here is that causes a hazardous atmosphere is combustible dust at a concentration that meets or exceeds its LFL. Again, if it's at the lower flammable limit or more, that's dangerous. Oxygen concentrations below 19.5 or above 23.5. And any other dangerous atmospheric condition like carbon monoxide or H2S. So what kind of information is going to be included on the entry permit? And this is going to be found under 1910 146F in the code book. The permit is going to identify the permit space to be entered, the purpose of the entry, date and duration of the entry for how long people can work on the inside, identification of the authorized entrants, who are they by name, identification of the attendants, again, who are they by name, identification and signature of the supervisor, the entry supervisor, who, as we mentioned before, could be either an entrant or an attendant, hazards of the permit space to be entered, whether it's going to be poisonous gases or noxious gases or lack of oxygen or flammable mist or vapor or whatever, control measures taken to isolate hazard, what kind of protective equipment, for example, acceptable entry conditions, whether it's going to be during the day or at night or things like that, results of initial and periodic atmospheric monitoring, so we're going to keep monitoring the atmosphere to make sure that the conditions do not change, thus necessitating someone to get outside or the use of additional protective equipment, and rescue and emergency services available. If someone is hurt on the inside, how can we extract them, and what kind of medical attention are they going to need? Communication procedures between attendants and entrants, whether it's going to be just voice or visual contact or what other kind of contact. Equipment, PPE, alarm system, etc. PPE stands for personal protective equipment, of course. Alarm system, etc. required for entry and rescue operations. And any other necessary information and other required permits, like if it's going to be considered a hot environment, then a hot work permit is going to be needed in this case as well. So basically this is a review of what's a confined space and what's the permit required confined space, and we talked about the three main duties that we have as an entrant, as an attendant, and as an entry supervisor, and then we talked about the information that should be included on the permit itself. So what is a confined space? Again, this is just for review. We mentioned three conditions for a confined space. A person can enter, difficult entry and exit, and it's not for continuous occupancy. What's a permit required confined space? It's a confined space with hazardous atmosphere requiring a specific permit. Should an attendant rescue an entrant if the entrant needs help? Yes or no? Well, it's not yes or no, it's somewhere in between. It's the attendant can enter or can help as long as they do not enter the confined space, because once they enter the confined space, they are not an attendant anymore. So basically, okay, but attendant cannot enter the confined space. What is the leading cause of confined space fatalities? As we have seen in most of the cases that we have discussed, it is the noxious gases or the lack of oxygen, so it's going to be asphyxiation. And that basically is our lecture for today for the confined spaces. I'll see you in another lecture.